Hey guys, my name is Boris and I'm a computer engineering student at the Technical University of Berlin. And on this channel I want to talk about things that I've learned and might bring you value, general educational topics and lifestyle ones. Today we'll go through the basics of Ros, and we'll, for example, take a look at several commands like Ros Run, roslaunch, how to create a Ros package, and add launch files themselves. So let's go. First, we have to have a basic understanding of Ros and a Ros node. Ros is based on a pub subsystem. It has a master node that manages the different topics that are published. When you write a program or a script, it is referred to as a node. This node can then advertise and publish data, or rather messages, to a topic, like the scan data of a LiDAR sensor, with a specific frequency. Other nodes can now subscribe to topics that exist and then work with the messages provided by the topics. So we now know there are these nodes that do the work and are your scripts or programs that you write that provide data to other nodes or just perform tasks. And it is fairly common to break down the architecture of your Ros system into multiple nodes that all have a specific task. And if you write your own messages, you have to define those and like the ones that you want to publish. And this is not really part of this video because it would be too much. And yeah. But if you are working with already existing topics, you will have to find out how the message is built, or rather the message structure, to be able to get to the data you want. One way to find out information is through the terminal command Ros Message Show. This obviously also works if you have forgotten one of your own message structures. Here, for example, we can take a look at the definition of the nav message's path message. And you can see it's built up of multiple other messages. It first has a header that contains some metadata, and it then starts with a new message type, or new message, the post-stamped message. And to be precise, it's a post-stamped array because it is a path that contains multiple post-stamped messages. And this post-stamped message then has a new header and then another message type, which is a pose message. And this pose message then has a point type or point message, which then eventually contains the X, Y, and Z data that you want to access. And then you would just access it in your code, for example, by your variable name and then poses, .pose, .position, .x, for example. And then you would access your X position. And the other way to look at this message structure is just to look at the online documentation. For example, you can just Google the message, nav messages path, and then look at the Ros documentation, and you'll basically just see the same information just in your browser. Some other very useful commands are, for example, the Ros Node List. And if we type this in, we can see that those are the nodes currently running with this application running. We then also have the Ros Topic List. And this command will show you all the currently published or advertised topics. And you can see there are a few more topics being published than there are nodes running. Because, for example, alone the move base node has multiple topics that are being published and being, well, worked with. We can, for example, also see this scan topic here. And something even more useful is the command rostopic echo, which displays the data in the message that is being published to the topic. Again, if we look at the scan data with rostopic echo scan, we can see its data. And this is fairly practical because we can now see that this simulated scan data that is going out of this little agent here is being published, and we can monitor it and look if everything is going fine. For example, now if we drive around, we can see that there is actually some data being published and the scan data changes based on the scan data, well, the robot is publishing. Okay, so we have nodes and we have topics, but how do we create a node that is registered by the master? Well, you have to differentiate a bit between a Python and a C++ node, but with both you will need a CMake list and a XML file that you have to manage. Luckily, there is a command with which you can easily create a directory or in Ros terms, a package with a CMake list and an XML file. For that, let's quickly change the directory to the Catkin workspace into the source folder, and let's here create the Catkin package. And we would create this package with the command catkin create package. The next argument would be the package name, so in this case let's call it Ros Basics, and the following arguments would be the dependencies of your source code that you want to write. In this case, let's just take standard messages, rosby and roscpp. And if we now open our file manager, for example, we can see our directory, or in Ros terms, package called Ros Basics. And if we enter this directory, we can here see the CMake list and the package XML. And this is already like a boilerplate or a template where you don't have to do much, except in the XML file, you'll have to manage your dependencies here. And in the CMake list, everything is done for you, but you will have to manage it later on if you're adding more dependencies or including some header files, or like the standard stuff that you have to do with a C++ project or file. With Python, you basically only need to write your node or your script, and then you have to include a command from the template in the CMake list. And this command is right over here. And this should basically be it, except you then have to change the script into an executable with the command change mod +x, and then you just write, for example, myscript.py. Good. Now we know about the basics of nodes and topics, how to look at messages, for example, through the terminal, and how to create a package. Now let's look at running a node. There isn't that much to say about it. You have the command Ros Run, which first takes the package name and then the executable name for arguments. For a bit more cool looking example, let's look at this one here. I've started an Arvis environment with a little agent that has to navigate through this flatland world. For that, he needs a global path and subgoals, which are calculated and published by a node called Spatial Horizon. So without it, nothing is working. As you can see, if we now want to enter a goal that he has to drive to, nothing is happening. So now let's start the node with a Ros Run command. This command would be Ros Run, arena Spatial Horizon node. And you can see it prints out Spatial Horizon node has started, and now everything should hopefully work out. And you can see everything does actually work, and the agent is driving around. Okay, now let's quickly navigate to the Spatial Horizon package, and this would be in the Arena Rosnav repo. Then we would go to, where is it, Arena Navigation, and then here you can see my package that I have created. And I have created this package exactly with the command that I've shown you before. So we are in this package, and here, as mentioned, you can see the CMake list and the XML file, and here in the source folder, you can see the executable itself. Okay, now you can imagine that with larger projects that have several nodes, it is quite annoying to start every single one by hand with a Ros Run command. And that's where a launch file, or launch files in general, come into play. Launch files basically start several nodes at the same time and set parameters. We'll get to those in a bit. But launch files can do much more than just that. If you look at this launch file here, for example, you can see that launch files can call other launch files, like so. Simply start a node like this map server node, or just group nodes. This grouping is interesting because with launch files you can basically have if-else cases where you start a node, a group of nodes, or just call a launch file based on parameters. This was a bit all over the place, so let's look at the exact calls. Starting a single node has a simple syntax. The name here is the displayed name of the node. When you, for example, look at the Ros Node List, this name would show up. PKG is the package name, and type is the actual executable. Calling another launch file is even more simple. You just have to include the path to the file and follow the syntax. Defining a group is also nothing crazy, as you can see here. In the body of the group, you simply again do the same node calls as discussed previously. Now you can also see you can start nodes or call other launch files dependent on some parameters. But how do these parameters work? Basically, there is a parameter server that the master also manages, I believe, and there all global parameters are available to all nodes. You can set parameters manually in the terminal with the command rosparam_set. Let's say, for example, you want to set an example parameter to the Boolean value true, or an integer to 7, or a string, just anything that is defined. Or you can just read the parameter with the command rosparam_get / example again. In most cases, parameters are initially set in launch files. Nodes in C++ and Python can, of course, also set parameters or read them and then work with them. You can also see the arg or argument keyword here. Basically, arguments have to be provided when starting a node or a program as usual. Parameters are similar, they also have to be started, but arguments can't be changed later on, and the parameters lay in the parameter server. So we have the keywords param and arg. An interesting functionality are the arguments, because as you can see here, they have a default value but can be changed when launching the launch file. Let me show you what I mean. For that, we first need to quickly look at how to launch a launch file, and it's very similar to Ros Run. The command would be roslaunch and then the package name and then the launch file, like in this example here. And in this case, we haven't defined any arguments or specified any new values for the arguments, and this would start the program or the launch file with default values, in which case this is a empty map. And yeah, now if we start a launch file and then want to type in some arguments, this is where the interesting things happen. We have, for example, an argument like local planner that we can change, and this will internally, so in the launch file, start a different launch file, as you can see here. We can also change the map on which our little robot will drive around. As mentioned before, we had an empty map, and now this map, for example, will be map 1. Let's quickly change the local planner to something like DWA, and let's look what will happen. And you can see the map has changed and the planner has also changed, but you won't be able to really tell, I think. But yeah. And you can do as many parameters or arguments rather in your project as you will need. Okay, to summarize, we have talked about nodes, topics, and the messages that are being published to those topics. We have looked at useful commands like Ros Topic Lists, Ros Node List, and at the commands to start a node or run a launch file. Finally, we took a closer look at the launch files themselves and had a brief introduction to the parameters. Of course, there is much more you can do with Ros, but I think those are the key tools that you need to get into a good Ros workflow. I am working with Ros and deep reinforcement learning in my bachelor thesis, and I have made a few videos and I will probably make more, and I've put them into a playlist that you can click up here if you think that this could be interesting to you. So, if you have enjoyed this video and found it helpful, please consider liking this video and subscribing to my channel. And yeah, with that said, thank you very much for watching, and I'll see you guys in the next one. Bye!